Greetings everyone, this is our report topic about solid mensuration by Group 6. Enjoy.
I'm Joshua Mabini to discuss problem number 1. Find the radius of the circle below. So in finding the radius of the circle, we can use two different approach, which is if the triangle is proven to be a right triangle, the radius is equal to half hypotenuse of the triangle, or which is c divided by 2 is equal to r, or by using triangle circumscribed in the circle formula, or area triangle is equal to a times b times c over 4 times r, and with the Herion's area formula for the triangle's area. Since the triangle inside the circle has all different sides, or the side are already given, we can use the case number 1 to prove that the triangle is a right triangle. So we use the size and use the Pythagorean theorem to prove that the triangle inside the circle is a right triangle. So a squared plus b squared is equal to c squared, which is 12 squared plus 5 squared is equal to 13 squared, and that proves both of the sides is 169 is equal to 169. That verifies that the triangle inside the circle is a right triangle. So, in finding the radius of the circle, since it was proven that the triangle is a right triangle, the radius is equal to half of the hypotenuse of the triangle. So, we divide the hypotenuse of the triangle, which is 13 divided by 2, that gives us 6.5 unit. So the area of the triangle, the radius of the circle rather, is 6.5.
Problem number 2. A dog is tied to one of the corners of the rectangle building using a chain that is 40 feet long. The dimensions of the building are 30 feet by 20 feet. If the dog can reach wherever the rule allows it to reach, what is the maximum area the dog can cover? So the illustration, which shows the top view. The area shaded represents the maximum area the dog that can cover, and it has a 20 by 30 building given. Dog is anchored by this point with a 30 feet, 40 feet of chain. A1 has a radius of 10, A2 with a radius of 20, A3 with a radius of 40. Solution. Maximum area that the dog can cover, which is equal to A1 plus A2 plus A3. A1 percent a quarter, A2 two, a quarter also, A3 3/4. He represents us pi r squared, which is a basic area of a circle, which is n, the percentage, the ratio of a circle. If it is a quarter, semicircle, three-quarter circle, or a whole circle, or any percentage. Now, so we continue playing the values. The area that the dog can cover is equals to 4,162.61 feet square.
So good day, sir. So I am Ashley Lunod and I will explain problems 3 and 4. So for problem number 3 is to find the value of x in the figure below. So at circle O, the prior interior angle of the other triangle is equated to x plus y plus z is equal to 180 degrees. And also angles 12 and 91 are equal since they are inscribed angles in the same arc. So we need to find the value of x, which is the other angle. So for our solution, we had x plus y plus z is equal to 180 degrees. Now, we all know that based on the equation 1, we know that 180 degrees is the total angle. So we can just subtract these two angles to 180 degrees. So in here, we transpose y and z to the other side to make them negative. So the two angles are 91 degrees and 12 degrees. So we will subtract them to 180 degrees. So we have here 180 degrees minus 91 degrees minus 12 degrees. So the answer will be 77 degrees. Then for problem number 4, the length of the sides of a triangle circumscribed in a circle is 10 cm, 15 cm, and 24 cm. So find the radius of the circle. So the triangle is circumscribed in a circle. So to find its radius, we need to use the Heron's area formula. But before that, we must first determine the value of S. So to determine the value of S, we must divide the sum of A, B, C by 2. So A is equal to 10, B is equal to 15, and C is equal to 24. So 49 divided by 2 is equal to 24.5. So we can now substitute this to the formula. So 10 times 15 times 24 divided by 4 square root of 24.5, open parenthesis, 24.5 minus 10, close parenthesis, then open parenthesis, 24.5 minus 15, then close parenthesis, open parenthesis, 24.5 minus 24, then close parenthesis. So we put that, we solve that in a calculator, and we will get the value of 21.9093 centimeters. So that's it.
Problem number 5. So find the volume of the solid. So this figure is what we call the frustum of a cone. So for the formula for the frustum of a cone, our volume would be pi over 3 height multiplied by height and the radius of the big circle and the radius for the small circle, add by the multiplication for the big and the small circle, the radius of the small and big circle. So our given is the diameter, so we just multiply it by 2 to get the radius. So here is 7 and here is 12 feet. So we must find first the height of our frustum here because it is not given. So to find it, we just use the triangle formula, and to find this here, we just subtract the big circle to the small circle, which is 12 minus 7. So it is now 5. So we let this x. So our x is 5 and our height is unknown. So for the solution to get our height of our frustum of our cone, so we draw it a triangle. We have here our slant height, our x, which is 5, and our unknown. So to get h, we use the formula h squared plus x squared plus our 13 here is our slant length. So we use this formula. So to get our height, so it would be now this. So we substitute our length is 13 and and our x is 5, we then get our height 12. Here, 12 feet. So in our volume, formula of our volume in a false form of a cone is this is 3 multiplied by r, the big radius of our circle, the small radius circle, and our multiply by the small and big radius of our circle. So we have the h, the big radius of our circle, and the small, and you can now substitute. H is 12, this radius is 12, this is 7, and 12 multiplied by 7. Just add this, and we now get the volume 3,481 cubic feet. Problem number 6. The surface area of a cube. So a cube here, we have our cube. Cube area is 246 square centimeter. So we must find the volume of the said cube. First is, so to get the volume, we have our formula. Volume is equal to side to the exponent 3. But our given is the area. So we know that the area of our cube is equals to 6 side multiplied by side square. So we have our A, and we want to get our side. Our A is 246 over 6 squared, 6s squared. So multiply by 6. The answer would be 41 s squared. So let's square it. 41 is s now is 6.4. So to get the volume, we just substitute 6.4 cube. Then our volume would be 262.53.
Problem number 7. A vessel in the shape of a cube measures 4.83 meters on a side is tightly packed with 8 balls and a pool of water. All balls are identical and are in contact with the walls of the vessel and adjacent balls. What is the volume of the water in the container? The container is a cube. In the illustration, show the side view of the cube with balls, which is identical. There are 8, tightly packed. The given is the S, which is the side of the cube, 4.83 meters. Requirement is the volume of the water. Solution, cube volume equals water volume plus 8 times the ball volume. So we get the water volume, which is the cube volume, minus 8 balls. The cube volume is S cube minus 8 times the ball volume, which is just a sphere, which is 4 pi over 3 times R cube. And we plug in the values, and we remember that R is equals S over 4, as in shown in the section. So we get the water volume is 53.68 meter cube. Problem number 8. The arc intercepted by a central angle is 3.5 inches. The radius of the circle is 1.5 inches. Find the area of the segments intercepted. So this the radius, the theta, the angle, L is the arc length. Arc length, or L, is 2.5 inches, R is 1.5 inches, and the requirement, the segment area, in inch squared, which is the shaded area, this. And the segment area has an area of 1/2 times r squared times open parenthesis theta minus sine theta close parenthesis, which is the formula, and the theta is in the radian, which is simplifies as arc length over radius. And we plug in the values, and we get the segment area is 1.8115 inches squared. Problem number 9. The median of the trapezoid is 37 centimeter, while its altitude is the 6.48 centimeter. Find the area of the trapezoid. So this is the illustration of the trapezoid. With the median given is 37 centimeter, the height or the altitude of the trapezoid is 6.48 centimeter. The requirement area of trapezoid in centimeter squared. The solution area of trapezoid equals median times height, which is the formula m times h. 37 times 6.48 equals the area of trapezoid, which is approximately equals to 239.76 centimeters squared. And thank you for watching.